Good day everyone, I am King Harold Santos and I'm going to discuss about the compressive strength of wood parallel to the grain in reference standard ASTM 143-83 or ASTM D19. Test for compressive strength of wood parallel to the grain. In reference standard ASTM D143-83 or ASTM D19. Wood has been used in a building construction for a variety of purposes due to its lightness, durability, and strength. The strength of the wood is influenced by the structure of its grain. Tensile resistance along the grain is much greater than the resistance between fibers. When subjected to bending, a piece of wood having grains that run longitudinally has strong tensile and compressive strength compared to cross-grain wood. So for today's objective, we are going to determine the strength of wood under compressive loading and to evaluate the strength of the tested sample against the allowable strength of its kind. Apparatus. We need a testing machine, load indicator, bearing blocks, ruler, caliper, and wood samples. Testing machine and load indicator are built in together. The bearing blocks, this is used to uniformly distribute the load over the ends of the specimen. Usually, bearing blocks are rectangular with plain bar or a circular plain bar. Ruler. Ruler are used to measure the length of the specimen. Caliper. Caliper are used to measure accurately the thickness and wideness of the specimen. Wood sample. The wood samples are the samples needed to perform this test. It must have a dimension of 2 by 2 by 8 inches or 50 by 50 by 200 millimeter according to a primary method specimens, or 1 by 1 by 4 inches or 25 by 25 by 100 millimeter according to secondary method of specimen. It is in accordance to reference standard ASTM D19 or ASTM 143-83. Procedures. Prepare a wood block according to the specifications of the laboratory instructor. Then, measure and record the dimensions of the specimen to the nearest 0.01 inch. Do not forget that the dimension must be 2 by 2 by 8 inches or 50 by 50 by 200 millimeter or 1 by 1 by 4 inches or 25 by 25 by 100 millimeter in accordance to the reference standard. And for the reminders, ensure that the end of grains surfaces will be parallel to each other and at right angles to the longitudinal axis. For the next procedures, Place the specimen in the testing machine. At least one platen on the testing machine shall be equipped with a spherical bearing to obtain uniform distribution of load over the ends of the specimen. Next procedures: apply the load continuously until the specimen fills. Records the deformation for each increment of 2,000 pounds load. Take simultaneous and deformation readings until the maximum load has been reached. First, deformation shall be read to 0.001 inches or 0.002 millimeter. Next, load compression readings shall be continued until the proportional limit is well passed. And for the final procedures, at the first sign of cracking, remove the strain device and continue loading until the maximum load is reached. Sketch the sample indicating the grain wood and manner of failures. After all the procedures taken, let's go for the calculations. So, data analysis. To find compressive strength of wood, we use the formula SC is equal to P over A, where SC is the compressive strength, P is the total load in kilogram, and A, bearing area in meter squared or millimeter squared. Surface area perpendicular to load application.
Good day everyone, so I will be reporting the task of static bending to wood. So wood is essential in construction because it absorbs some heat and it usually used in concrete poles. Also, it is resistant in electrical current, making it an optimal material for electrical installation. So for best result, we will first put it in the static bending test.
Bending test is an important engineering test that is conducted on timber to determine its modulus of elasticity and the shear modulus of a given sample of wood using static bending. So these are the useful terms when conducting this test. First is shear force, elastic curve, flexural stress, stresses, and flexural equation.
So let's define these useful terms. First one is shear force. It is the sum of all forces acting perpendicular to the suction or forces which tend to slide toward the suction in each other. Second is elastic curve. It is a line representing the deformed form of the center line of the beam. Third is flexural stresses. These are stresses produced by the bending moment. The fourth one is stresses. It's the internal resistance of the material against loading current. The last one is flexural equation. It is the fundamental relationship between bending moment and geometry of deformation. So these are the objectives of the experiment. The test is carried out to study the bending or flexural behavior of the beam to determine the modulus of elasticity and modulus of rupture of the wood.
So the materials we will use in this experiment are universal testing machine, load-bearing block, wood specimen 0.75 meter long, supporting apparatus, and deflection apparatus. So these are the procedures of our experiment.
So that is the end of the video. I hope you have learned something.